Hi friends, welcome to all. In this video, we are going to configure static summary route. Friends, please subscribe, share and like our channel. And also, if you wish to get any technical support, you can contact our team. All the details given in the description below. Coming to the configuration, we will design the topology. We will keep two routers, R1 and R2. Then two switches 2960 series, S1 and S2. Then we will keep some end devices. So here we have PC1, PC2, PC3, PC4, PC5 and PC6. We will delete this PC0. We will connect all these devices using copper straight through. From R1 a gigabit Ethernet 0/0/0 to R2 G0/0/0. Then from R1 G0/0/1 to S1 G0/1. The same way from R2 G0/0/1 to S2 G0/1. Then we will connect all these end devices one by one. FA0/1, FA0/2, FA0/3 and FA0/4. Then here the other side, FA0/1 to PC1, FA0/2 to PC2. Here we are going to configure VLAN in this R1 LAN side. And here we can see right now total we have three networks. Let me highlight those networks. So here we have this network. Then the other side, here we are going to create VLAN. We can see this site. We are going to create 4 VLANs. Suppose PC3 is in VLAN 10. Then PC4 is in VLAN 20. Then PC5 is in VLAN 30. And finally PC6 is in VLAN 40. And here we got 1.2 point network between R1 and R2. Okay, consider this is VLAN 10 here, PC3, VLAN 10, and we will use the address 192.168.1.0/24 network. Then PC4 is in a VLAN 20, and here we will use 192.168.2.0/24 network. And here this PC5 is in VLAN 30, and we will use 192.168.3.0/24 network. And here finally PC6 will put in VLAN 40, 192.168.4.0/24. Here we are not going to configure the entire VLAN concepts, like we are not going to configure the VLAN name or a native VLAN, etc. So here we focus on static summary route. So we will have these 4 networks here with these 4 VLANs. And we have a VLAN related videos in our playlist. You can go through that. Now here between R1 and R2 we will use 172.16.1.0/30. Then here in this R2 LAN we will use, okay, we will take from A class 10.1.1. We'll give 10.0.0.0/8. First we will configure our switch S1. Enable configure terminal. We will set the host name S1. No IP domain lookup. We will create the VLANs, VLAN 10, VLAN 20, VLAN 30 and VLAN 40. Now we will assign ports to the VLAN. We'll go to interface FA0/1, which is connected to PC3. So that should be in VLAN 10. Switch port mode access, switch port access VLAN 10. Now we will go to interface FA0/2, which is connected to VLAN 20. Switch port mode access, switch port access VLAN 20. So that FA0/2 is connected to PC4 and we planned PC4 will be in VLAN 20. Next is FA0/3, which is connected to PC5 and we will assign this port FA0/3 to this VLAN 30. We will go to interface FA0/3, switch port mode access, switch port access VLAN 30. Then we can see FA0/4, which is connected to PC6 and we will assign this port to VLAN 40. Interface FA0/4, switch port mode access, switch port access VLAN 40. We can verify our configuration and show VLAN brief, and here we can see one is assigned to VLAN 10, interface FA0/2 is assigned to VLAN 20, 3 is assigned to VLAN 30 and FA0/4 is assigned to VLAN 40. Next we are going to configure R1 router on a stick inter-VLAN routing here. Before that, this interface which is connected to R1 should be trunking because we are going to configure a router on a stick inter-VLAN routing. So we will configure this trunking here on S1 interface G0/1. Interface G0/1, which is connected to R1. Switch port mode trunk. Now we will go to R1. No. Enable configure terminal. We will go to interface G0/0/1, which is connected to our switch. So we will create the sub interface. Interface G0/0/1.10. So this is for VLAN 10. Encapsulation .1Q 10. Now we will set the IP address. So this address will be the default gateway for all the PCs which are in VLAN 10. Here we will set to 192.168.1.1. We already specified here we will use 192.168.1.0/24 network for VLAN 10. So we will use the first usable IP address as the default gateway. Then subnet to mask. Next, we will create a sub-interface for VLAN 20. Interface G0/0/1.20. So this is for VLAN 20. Encapsulation .1Q20. All right. Encapsulation .1Q20. Then we will set the IP address 192.168.2.1. So here we can see that VLAN 20. Then the subnet mask. Then we will create sub-interface for VLAN 30. Interface G0/0/1.30. Encapsulation .1Q. VLAN ID is 30. Sorry, it's .1Q30. We will set the IP address 192.168.3.1. Then subnet mask. So here we can see for VLAN 30, we decided to use this address 192.168.3.0/24. Next, we will create a sub-interface for VLAN 40. Interface G0/0/1.40. Encapsulation .1Q. This is for VLAN 40. ID is 40. IP address we choose here 192.168.4.0. Sorry, 4.1, first usable IP address. Then the subnet mask. Now we need to activate all these sub interfaces. For that, we need to go to the actual physical interface, that is interface G0/0/1, and we need to give no shutdown command so that all the sub interfaces are also activated. We can see those messages here. Sub interface G0/0/1.10 changed state to up, and also protocol up, and we can see other interfaces, sub interfaces. We can verify that. Show IP interface brief. We can see all the sub interfaces and its IP address here. Now we will assign IP address to these PCs. Coming to PC 3, 192.168. So this is 1 dot. We'll assign 2. Default gateway 192.168.1.1. We already configured sub interfaces. Coming to PC 4, 192.168.2.2. Default gateway is 192.168.2.1. Then coming to PC 5, 192.168.3.2. Default gateway 192.168.3.1. And PC 6, 192.168.4.2, 192.168.4.1. Now we will test the connectivity from PC 3. We will ping 192.168. We will ping to PC 4. So that is 2.2. And we are waiting for the replies. So here we can see we got the replies. Now we will ping to PC 5 192.168.3.2. We may get one request timed out. Yeah, so we get the replies here. Now we will ping to 192.168.4.2, that is a PC6, which is in VLAN 40. Okay, we get the replies. Now we will configure the link between R1 and R2. We will set the IP address for this interface G0/0/0. Enable configure terminal. So here I did not set the host name. Let me set the host name as R1, and also I'll give IP domain lookup. Okay, we'll go to interface G0/0/0, which is connected to R2, and here we took 172.16.1.0/30 as the network address. So we will set the IP address for this interface 172.16.1.1. Then the subnet mask 252. Activate this interface, no shutdown. Now the other side on R2 interface G0/0/0, which is connected to R1. Now enable configure terminal. Just I will set the host name as R2, and now IP domain lookup. Now we will go to interface G0/0/0, and we will set the IP address 172.16.1.2. Then subnet mask 255.255.255.252. Activate this interface, no shutdown, and we can see the link between R1 and R2 is up. Here we will test the connectivity. We'll ping to R1, ping 172.16.1.1. Okay, so we get the success rate. Next, we are going to configure this R2 LAN, and here we are not going to configure any VLAN. We choose here 10.0.0.0/8 as the network address. We will configure this interface G0/0/1 on R2. Configure terminal. We will go to interface G0/0/1, and we will set the IP address. I will give it 10.1.1.1. Okay, 255.0.0.0. So here we used the A class IP address. No shutdown. Activate this interface. Okay, we will configure IP address for these PCs, PC1 and PC2. 10.1.1.2 default gateway 10.1.1.1. Here 10.1.1.3 and the default gateway. We will test the connectivity here. We will ping to the default gateway 10.1.1.1. We get the replies. Then we will ping to PC2, that is 10.1.1.3. Now we are going to configure the static route. So here we can see one network, and in this site we got 4 networks. We can configure all the 4 networks in this router R2 as static route. But here we are not going to configure all the 4 networks. Instead of that, we are going to configure summary route for all these 4 networks. Here in this R2 is aware of these 2 networks, that is 10.0.0.0 and 172.16.1.0. We can verify that and show IP route. So here we can see 2 connected network, and this router is not aware of all these 4 remote networks. The same way on R1 is aware of these 4 networks and these directly connected networks. So total 5 networks, 5 directly connected networks. So we can verify that. Show IP route. So here we can see all those 5 connected network, 172.16.1.0, then 192.168.1.0, 2.0, 3.0, and 4.0. So this R1 is not aware of this remote network 10.0.0.0. First of all, we will configure on R1 and we will configure static route for this remote network 10.0.0.0. So coming to R1, we will give IP route. The remote network is at 10.0.0.0, then to mask 255.0.0.0. Then we can give either exit interface or the next hop address. We will give next hop address, the IP address of this interface G0/0/0. So it's 172.16.1.2. Next, we are going to configure the summary static route on this router R2. So we must find the summary route for these 4 networks: 192.168.1.0, 2.0, 3.0, and 4.0. Now we will find this summary route. So for that, we need to identify common prefixes. So we should identify for the longest common prefix, that is most significant bits shared by all the subnets. So here we got 4 subnets, I mean 4 networks: 192.168.1.0, 2.0, 3.0, and 4.0. We will do that. We will identify that common most significance bits. So here we are using the address 192.168. We can see these 2 bits, I mean 2 octets are common in all 3 networks, 192.168 dot. Next one we can see it's 1, 2, 3, and 4. So we are going to write in binary. So the binary of 1 in 8 bits, 1, 2, 3, 4, 5, 6, 7, 8 dot 0. So for all network, the last octet is 0 only. And the second network is 192.168. There is no change. Then the third octet is 2. That is 0, 0, 0, 0, 0, 0, 1, 0 dot 0. Okay. Then the third network is 192.168. We can see these first 2 octet we are not changing to binary because in all network they are common. Then it's 3, 0, 0, 0, 0, 0, 0, 1, 1 dot 0. Then the fourth network is 192.168.000000100 dot 0. Now we will identify these common most significant bits. That means we need to start from the far left side. Okay. So here we can see all 4 network. First octet is 192. So there is no change. We will write 192 as it is. They are all common. Then we can see 168 on all 4 network. It is common. Then here we can see the 17th bit, that is all zeros. So they are common. So we'll write as it is. Then 18th bit we can see common, it's 0. Then 19th bit again 0. Then 20th bit all common, so we'll write 0. Then here we can see that 21st bit all 0. Here we can see that 21st bits all are 0. So we'll write 0. Then thereafter we can see it is not common. We can see here 1, then 0, 0, 0. They are not common. And here also we can see they are not common. So we can put a partition here. And here we got 3 more bits. We will put all those zeros, 1, 2, 3. Then finally we got all zeros, dot 0. We need to find the prefix here. So it is so easy. We should count the number of common most significant bits in this given networks. So we can see this is 192 is 8 bits, 168 is also 8 bits. So we get 8 plus 8 is 16, then 17, 18, 19, 20, 21. So most significant bits, common most significant bits are 21. So here we use a /21. So we can change it to 192.168. Here all zeros, that means it 0.0/21. So 21 means subnet mask is 255.255.248.0. Now we got our summary route. So using this summary route, we are going to configure the static route on R2. Coming back to our topology, we are going to configure a static summary route on this router R2. We already calculated our summary route. Coming to R2. Configure terminal. IP route. Our summarized route is 192.168.0.0. Then subnet mask 255.255.248.0. Then we can use either exit interface or the next hop address. Here we are going to use a next hop address 172.16.1.1. The IP address of this interface G0/0/0 on R1. So which goes towards these networks. Right. So we can verify this. Show IP route. Here we can see that the summary route. Now we need to test the connectivity. We configured static summary route on this router R2, and we will test the connectivity from PC1. We'll ping to PC3, PC4, PC5, and PC6. Ping 192.168.1.2. So we can ping the default gateway or we can ping to the PC. We can see we get the replies. We'll ping to 2.2. We get the replies. Then we'll ping to 3.2 and finally 4.2. So here we can see we did not configure all the networks as a static route here. So we found the summary route and we configured that summary route as a static route here on this router R2 so that we can reach to all these networks. Friends, that's all in this lab, that is configuring static summary route. Please subscribe, share and like our channel, and if you have any doubt regarding this activity, please message us. Stay connected. We will meet again with the next video. Thank you.